Now, a lot of times you have sections in your web.config file that you'd rather not be in clear text, like connection strings, for example. Sometimes you have to put passwords in those connection strings because you can't use integrated security for one reason or another. And it would be nice to be able to encrypt the web.config file. The reason why you might want to encrypt it is because if, just for some crazy reason, somebody was able to download the source of that file, they would automatically have the password. If it's encrypted, on the other hand, the user would not only have to get the source of the web.config to get the ciphertext, but they'd also have to somehow figure out how to get the key off your machine, which is stored somewhere else, in order to figure out how to decrypt it. So it raises the bar just a little bit, and it's a good idea if you have secrets that you need to keep out of, that you need to protect in your web.config file. Now, ASP.NET does provide a couple of different ways of approaching this. The default uses an RSA key that's created for you. There's a couple of different providers. The RSA provider is the default. And the reason for that is because you can export that RSA key and you can import it on all of the machines in your web farm, if you have a web farm, so that they can all encrypt and decrypt the same way. That allows you to copy an encrypted config file to a bunch of different boxes in your farm, and they all know how to decrypt it nicely. There's a different provider that you would have to, your command line would be a little more complicated if you wanted to use this. It's just a wee little bit more efficient, and it uses a machine-specific key that doesn't work well in a web farm. But I'm just going to use the default RSA provider and show you how to encrypt connection strings. Now, if you want to know more detail about how to do this, there's some great security guidance. There's some how-tos up there about how to use RSA and how to use the other provider up at msdn.com/security guidance. Look for the how-tos. So without spending too much time on the slide, I'd just like to show you how this is done. Let's say, for example, I just want to take this existing application that I have and I want to encrypt the app settings section. You can also do this with connection strings, but I'm just going to do it with app settings since it's there. So I'm going to go to All Programs, Visual Studio 2008. I'm going to bring up a command prompt that has all my paths set up because I need to run ASP.NET regis. It's just a little helper tool that comes along with Visual Studio. There's a lot of different ways to run this tool. I find it most convenient just to go over to the directory where my web.config file is. So I'm going to go into Demos. Let's see, this one's called Roles Demo. And I'm just going to run ASP.NET regis. And then the command that you want to pass in the switch is -p. P stands for protection. So you're talking about protecting a section of your web.config. E stands for encryption. I want to encrypt it right now. And then F stands for file. That says I'm going to pass you the file or the directory in the file system where I want this encryption to happen. So then I pass in the name of the section that I want to encrypt, app settings, and I pass in the directory name, which is just dot. It's where I'm at now. And this will look for the web.config file in this directory. We'll look for the app settings section, and we'll encrypt it. Okay? So now if I switch back over to Visual Studio, you'll notice that my config file has been changed, and my app settings has gotten a lot fatter. You'll notice that you no longer see the data in there, you just see ciphertext. Okay? And that's an awful lot of ciphertext there. I'm not going to go through all the details of this, just suffice it to say there's enough information here that will allow your application to continue to function. Right? If you remember what this looked like before, that was the path to where our roles file was. And this application wouldn't work unless it could find roles. So let's see if I can still log in. Keith, log in. Keith, log in. Oh, let me actually go to the default page, sorry. All right, here's the default page. Let me log out, log back in, Keith. Everything's working fine. I can get to the roles file. And the reason for that is because there's enough hints here that the system can figure out what key it needs to load in order to decrypt this. Now, this key is stored on the machine where you're at. And so if an attacker is able to somehow compromise your process and run arbitrary code in your process, he's going to be able to decrypt that section just like you could. But if he simply downloads your web.config file somehow, If he somehow figures a way to download that file, he won't be able to do anything with this ciphertext unless he is able to also steal the machine key. Now, you can copy this because this key is stored on the machine. You can copy this setting up to your web server and it should work just fine. In fact, you can copy it to a web farm as long as you sync the key on all of those machines. But what if you want to make a change to this? What if you need to change the path where that file lives or something like that? Well, this is where you go back and you say, instead of PEF, you say PDF. D stands for decrypt. So when I run that, that's going to take that machine key into a decryption and allow me to make a change to this. Let's say demos 2, let's say now. I know that that's not correct, but let me go ahead and re-encrypt it now. Right? So now we've encrypted it with, it's the wrong path. The application should now fail, just to show that it's actually decrypting, right? If I refresh this thing, could not find a part of the path. So the beauty of this technique is that as a developer, you don't have to worry about decrypting this at all. The system takes care of it for you. It's a really easy way to raise the bar just a little bit for secrets that you might have to store in web.config.